Hello and welcome back to the Staad Pro class. In the previous class, we had done a frame that looks like this, a single story frame. And in this class, we'll be working on a frame, or what is this called as a portal frame multi-story. Okay, we'll be working with something like this. We'll be trying to use this beam and column, what can I say, sizes and everything, and we'll try to do as much as possible to the guidance that is given here, step by step. All right. So with that being said, let's get started. So very quickly, what I'm going to do, click on new project. I'll use space. Let me just do multiple portal frame. Okay. Uh, Next, add beams and finish. All right. So very quickly, we'll get all this information for us. We'll close this. And now, if I were to open up the diagram for you, see here, the distance is 4 meters and 5 meters here. Let me try to just move it a bit down. Okay. So this is 4 meters, this is 5 meters, and 4 trees there. So we have a general idea of how we have to start mapping this. Okay, so what I have to do basically is I have to start with this point. I have to consider my origin point first. That's very important. So I'll consider this point as my origin, 0 comma 0 comma 0. Okay, and how we did last time, this values y increment will be there, x and z will remain 0. Okay, so I'll try to recreate this drawing very quickly in the paint so that we have all the node points for us to work with. Okay, so let me do one thing. Okay, I'll just delete this extra loads from here. Okay, I'll use this and this. Same thing I have to do for this as well. Okay, and on top of this we have one more frame. Just a second. Okay, so again this is going to be 0 comma 4 comma 0. Let me just write here what's the distance for that. Again 3, 4 plus 3 is 7, so 0 comma 7 comma 0, 0 comma 7 comma 0. All right, this is going to be what? This is going to be this point here. Okay, and then I have to start adding this middle point and this point. So this the distance is 4. This is going to be 4 comma 0 comma 0. Okay, it is not moving in y, it is not moving in z direction. So I have to just delete this. The distance is 4 meters and then 5 meters. So this is going to be 4 comma 0 comma 0. Not wrong. 4 comma 0 comma 0, and this is going to be 9 comma 0 comma 0. 9 comma 0 comma 0. All right, so this much is done. Let's move up a little. Now here what happens, the x values will remain same, the y values will increase by 4. Okay, same principle will apply over here. So it's going to be 4 comma 4 comma 0 because there is no increment in that direction here. Z will remain 0 everywhere. Okay, this is going to be 9 comma 4 comma 0. All right, why it is increasing 4? Because we are moving 4 in y direction. Now we are moving 7 now. So again I have to just very quickly add these values. It's going to be 4 comma 7 comma 0. Okay, x will remain constant, y is increasing here. Okay, because we're increasing y direction. From origin only 4 meters we have come in x, and y we have come 7. All right, and here is going to be 9 comma 7 comma 0. Okay, so these values I have to input into my system, and doesn't matter in what order you input them. Okay, at the end of the day, what you have to do is you should be in a position to recreate this drawing there. Okay, so what I'm going to do is I'm very quickly going to add all this. I'll add the base first, then add this, and then I'll add this. Okay, that's how I want to go in this particular order. So first is going to be 0, enter. Next is going to be 4, enter. Next going to be 9, enter. Okay, 0, 4, and 4 plus 5 is 9, so 9 over there. So base 3 is done. Okay, I'll just see them in the front view like this. Next, I have to add the same 0, 4, 9, and I have to increase them by 4 in y direction. Okay, so 0 is going to come here, and 4 is going to come here, enter. Then 4 is going to come here, and again 4, enter. Second point. From here, 4 is going in x direction, 4 is going in y direction. So we're getting this point 4, comma 4. All right, and then I have to put 9, 9, comma 4 again here. All right, so I get that point. I'll zoom out a bit more. Again 0, and this time I have to add 7 here. Why am I adding 7? Because the point is at 7 there. Okay, 4 plus 3, this point is at 7, this y vertically. All right, and then x is 4, y is 7. Then x is 9, y is 7. Okay, so very simply we have done this. I want you to see this instead of 3s. Okay, let me just take my node cursor first and select the node of 3. Okay, so what is happening here? X is moving, y and z are constant. Okay, so 0, 4, 9. So this is 0, comma 0, comma 0, 0, comma 4, comma 9. Okay, if you just select this, you can see that it becomes highlighted. This is going to be 9, comma 0, comma 0. Okay, the first 3 set is done. Next I have to do these 3 sets. For this, the value in y is going to move. Okay, 4, because it's original level, so x value is not going to move. It's moving only in y direction. Then what happens for this particular thing? It is moving both in x and y direction. So I get 4, comma 4. Okay, and this moving in both x and y direction again. So I'll get 9, comma 4. X is 9, y is 4. You can see x is 9, y is 4. All right, so the same thing I'm repeating for the top order as well. All right, so I hope you have no doubt with this. If you have, let me know. Okay, so once that is done, very quickly I have to come here. I have to see where all my beams are there, and I have to just assign my beams. Okay, don't go and assign like this. It will become one single beam. Okay, let me just show it to you. See, it becomes one single beam. I want it to be two separate beams. Okay, just a second. Let me use the controls. If that's much better. So I'll add one here and here. I'll have to go node to node. Okay, I'll add node to node like this. Right, escape. Again, you can just come here and add them from here to here and here to there. Okay, so we have some resemblance to what we have done here. Next, I'm going to go to my tools and I'm going to check for beam dimensions. Okay, display. All right, so this is 4, this is 3, 4, 3, 4, 3. Same thing is here, 4 and 3. Okay, next we have got 4 and 5. We have got 4 and 5 here. All right, so what we had done here is correct. Okay, whatever values we had put here is correct, because based on those values only we have corrected this one. All right, so tools, I'll go and I'll just get it off my, remove this and remove them. Okay, so that much is done. Next I have to see my base condition. The base condition is fixed, so I'll just come to my general properties. I have to send properties first, right? So if you see, for beams it is 230 cross 450, and for column it is 230 cross 600. So I have to create two properties here. Define rectangle. Okay, that is 0.23 cross 0.45, 0.23, sorry, 0.45 and 0.23. Okay, width is 0.23, depth is 0.45. Depth is always more in a beam unless and until you're trying to do a hidden beam. Okay, so width is 0.23, depth is 0.45. Add. All right, close. Define again rectangle. Depth is 0.6, I believe, for the second one, and depth is 0.23. Let me just cross check. For column it is 0.23 because 600. Yeah, so depth is 0.6 and this is 0.23. Add. Close. Now I have to add these things. All right, so what I can do is I can select them, hold control, select them like this. Okay, one more thing is, firstly I will select the concrete property that you want to assign. Okay, then you come, hold the shift button and select your columns, because here clearly they have mentioned that column size is going to be 230 cross 600, and there's no way that these are columns. Okay, columns are always vertical members. All right, so you should do that and click on assign and click on yes. See, it gets assigned easily. Now what I have to do, come inside the concrete property first, hold the control button, shift the beams, sorry, select the beams that I want to assign the property to, and then just click on assign. See, by default assign to selected beam becomes active for you. Click on assign and click on yes. Okay, if you want to see this in 3D, it looks something like this, like a proper portal frame. So once that is done, I'll come to my support reactions. I'll create my support. Fixed support is given there, so I click on add, select this, yes, use cursor to assign. So I can assign my, okay, one more thing, hit shift K. Okay, shift K to get all your node points, shift K to remove them. Okay, so use cursor to assign, click on assign, and you can just assign it like this. All right, the keys shift K shortcut. Okay, your node points will go and your node points will come back like this. Okay, it will help you assign your supports very easily with this option. So hit escape when you're done. Okay, and then what is left out? Properties assigned and supports are assigned. Next is load and definition. Okay, so load case details, add the very first case that I have to add is that case. Okay, we'll add that load, we'll add it, close this, select this, add in this our case. Okay, self-fed case. I can do assign to view, assign yes. Okay, again I have to come back here, not here. I have to come back here, click on add, and I have to add what? Live load. Okay, LL, live load, add, close. Now in this empty case, I have to add multiple loads. Okay, will come from top to bottom. So we can see it is given 15 kN per meter live load, and it is given 10 kN per meter. And we know how we have to apply this. So we have applied this already. So we click on live load, and we come to our member load, and we go for trapezoidal first. Okay, one is going to be 0, one is going to be minus 15. All right, 0 is this point, minus 15 is this point. The distance is going to be 1 meter. If you see the diagram, I have explained this already. How much is the distance? Okay, if you have confused, please go back and rewatch that video. We have applied this kind of load already. Okay, add, close, select this, and use cursor to assign. Click on assign and assign it over here. Okay, let me just see. Oh wait, we have some distance in the other end as well. So let me just come here, select this, click on edit. Distance is 2. Change, close. Just a second. Edit. This 2 plus 1 is 3. So I have to give it 3 here. Change. Okay, now it's coming properly. Okay, so for those who are still confused, let me just come back over here. I think we had done CC here. Okay, to open here, wherever you're applying this load, the distance from the edge of the beam to the starting of the load is going to be D1. From the edge of the beam to the end of the load is going to be D2. Okay, so here they have given 2 meters from this and 1 meter from here. So the D2 will become 3 and D1 will become 1 meter. That is what I have given here. Okay, let me just edit this and show it to you. 1 and 3. Okay, D1 is 1 meter from this point to that point. D2 is 3 meters. Okay, so the first load is assigned. Let's go back here. Oh, sorry. Again, load and definition, live load, add. Okay, now I'll come again to member load, and this time I can go for my linear varying load, and you can see the second load that I have has got 10 kN per meter kind of load, and it is coming in the middle. Okay, so W3, I'll add let me see, minus 10. Okay, or sorry. Okay, so minus 10 is there. Let's add this. Let's see how I can manipulate this one. Use cursor to assign, will assign this. So we are getting the load all the way here. Edit. Okay. Um, I can counteract this problem. Let me just delete this load. We'll add live load, add this. Okay. We'll come back to member load and we'll add tabular load only. Okay, this is going to keep it 0. And what is the load next? 10. So we'll add minus 10 here. Okay. The value was how much? The value was 1. And I'm going to add until the midpoint. Okay, and then I'm going to change the values from here. So what I'm going to do is 1, and I'm going to give 2.5. Okay, 1 and 2.5. Let's add this, close it, select this, use cursor to assign it. We'll assign it like this. So the first half is done. Then I have to add the next half. So live load, add, member load. I'll come back here to this one, trapezoidal load. Okay. This time I'll change the values. It's going to start with W1 as being -10. Okay. And W2 is going to be 0. All right. And the load will start at what distance? 2.5, and 2.5 plus 1.5 it goes. Let me just open the calculator. 2.5 plus 1.5. Okay. 4 meters. All right. So 2.5 and 4. Add, close. Okay. Select this. Use cursor to assign it. We can assign it. Okay. So what have we got? We have got a load that looks just like this. Okay. Simply put, D1 was what? 1 meter, and half the distance I had to consider because I was adding only the first half. All right. So the distance was what? 3 divided by 2 is 1.5. So whole thing became 2.5. Okay. Then I repeat the process again for the other side. Okay. So if you have doubt, let me know. All right. There shouldn't be any because this is very simple. That what we have done here. Okay. We started at 2.5. That was a midpoint for this point. The starting of node was 2.5 from this node, and the ending was 2.5 plus 1.5 of this 3. That became 4. Okay. So we have assigned that load. Fine. Next, what we have? We have one more load here, minus 40 kilonewton. Okay. So again, live load. You click on add. Again, I'm coming from member load, concentrated force. Minus 40 I'm going to give. Okay. And no values over there. X-axis, add, close, select this, use cursor to assign, and we'll assign it over here. Okay, then automate GX, change. Okay, it's coming in the middle. I want it to come on the top. So what I have to give value here, the value is 3 meters. So let me just try to give 3 meters here as distance as D2, change. Okay, so there we can see the value as it has gone there. Okay, so like this trial error you have to do, and you can just get all those values done easily. Okay, so once that is done, next we have got 20 kilonewton UDL. All right, so just click on live load, add, member load. We have got uniform force minus 20, add, close, select this, use cursor to assign, we can assign it over here. Then we have a point load, I believe, 50 kilonewton point load, it is 5, so 2.5 is given, so it's coming in the middle. So again, live load, add, we have to add concentrated force this time, member load, concentrated force, I think it was 50, yes, so I'll give minus 50 over here, minus 50, okay, it's coming in the mid, so I don't have to give any values here, add, close, select this, use cursor to assign, and I am able to assign this load. Okay, so that much is done. Next, I'm getting one more load, 30 kilonewton. Okay, it is coming 2 meters from the bottom. I think rest everything is covered. Only this one last load is left out. So live load, can add. Okay, again I have to go to member load, concentrated force minus 30. From the bottom it was coming 2 meters, so 2 GX, add and close. Select this, use cursor to assign, and we can assign it like this. Okay. So once that is done, if you want to see the values, all you have to do is click this part, load values, apply. Okay, so you can see 15 is there, minus 10, 0, 0, minus 40, minus 30. Okay, whatever values they had asked us to put, we have given all those values. Okay, one more thing that I wanted to share with you here is, you can click on add. There is something called as uh, uniform movement. Okay, let me just show you, for example, minus 10, I'll add and close. Okay, so let me just click on use cursor to assign, and you can just assign it over here. Let me go for 3D to show it better. See, it looks something like this. Okay, so this is basically what a moment. Okay, that is being acted on your being portion. You can edit this and change its direction. All right, you can change it, and you can see it will add in different directions. Change it, you can see it adding moment, bending moment. Okay, you must have worked on these problems in your class where some bending moment is actually acting in the system, and you have to add this bending moment to your system when you're calculating your shear force and bending moment and everything, the reactions for this. Okay, so if you just change from minus to positive, it will change the direction of movement. All right, so even this load is there. How do I apply this load? Let me just show it to you once more. Live load, go to add. I went for my member load and I went for uniform force. I gave here minus 10. Okay, click on add, close, select this, and you can assign. It will come something like this, but then you can select the load. Okay, click on edit, and you can change its direction to whatever uh, way you want. Okay, change. We know that MZ is our major moment. Okay, bending moment along MZ. Okay, so we are changing along GZ value, and because GZ is global. Okay, so you can do that much. All right, so you can add loads like this. So once all of that is done and you are sure that you have added all the loads and everything is assigned, again the simple steps will follow from here. Command, analysis, perform analysis, all. Okay, analyze and analysis, and save. Okay, go to processing mode, click on done, click on OK, and same thing, control and move the scroll button, and you should be able to see that see the movement. Okay, if you can see the in the front view, and let me just hold control and move it a bit more, and you can see it is swaying in this direction towards the left. Why is it swaying there? Because we've got two constant forces acting on the same direction. Okay, trying to sway the frame in one direction. Okay, so results, view value, uh, nodes, global x direction, annotate, and you can see all the values that are coming in the x direction, the amount of sway you're getting in your system. You can remove all. Let's turn this off. Let's open up the mean major bending moments. Okay, let's annotate them all. Okay, you want to see this maximum value, just see the maximum value first. You want to see the n values, you see the n values first. Okay, and again you have to hold the control button and scroll like this. Okay, and if you're like, no sir, I'm not able to understand, there are so many values here, what I want to do is just select the first part, right click, and do new view. Okay, what you have to do, select the first part, the top part, right click, click on new view. Okay, create a new window for the view, display the view in the active window. I'll do create a new window for the view and click on OK. Okay, once you do this, just click on your MZ values and you will be able to understand them much better. Okay, if you want, you can do it separately also, for just one portal frame first, then for the next portal frame. Okay, you can do that. So MZ you have checked. Same thing you have to do for your f of y also. You have to go for results, view value. Okay, beam results, maximum if you want to check maximum. Uh, yes. Okay, you can see all these values there. Okay, remove all, and then I want to check my reaction forces, global x, y, and z. Annotate. Let me just turn this off. Okay, these are the values that I basically check when I am doing my foundation design. Okay, how much load I'm getting in y direction, because that's my what, vertical direction. Okay, axial forces, how much amount of axial forces I'm getting, what I'm getting, I'll check like this, and then I'll show you how to do all that in the future classes. Okay, so like this, yeah, you can not just model but also put the loads and analyze your portal frames. Okay, so I hope you understood. If you have any doubt with respect to the modeling which we have done here, okay, or the application of load, because I applied multiple loads here. Okay, that's why I just picked up that problem, because so many different kind of loads we have to apply in our system. Okay, if you have made out on any point, please let me know. Okay, I'll try to clear it out to the best of my ability. Okay, just watch the video once or twice. Okay, I'm sure it will clear your doubts. All right, I think the most issue might come here in this part. Okay, but it is very simple to understand if you watch it 2 times. Okay, so I hope you have understood this. In the next class, we'll start picking up proper problems. I'll show you how to start modeling your building from scratch inside Staad Pro, and we'll pick up some important concepts such as beam orientation, how to do that, how to toggle. Okay, one more thing, uh, how to toggle your load. Okay, that's also a very important concept that you should know. For example, I didn't want to assign this load. Okay, I didn't want to assign this. Okay, and how do I remove this without deleting it? Okay, so what you can do is toggle assign. I didn't want to assign it over here, I wanted to assign it over here. Okay, so you can just click on toggle load and click on assign and click here, it will disappear. Okay, so if I want to assign this, select this, click on use cursor to assign, click on assign and assign it here. Okay, but now you're like, no sir, I don't want to delete this load, I just want to remove it from here and assign it over here. I by mistake I applied the load here. Okay, so how can I remove it? So just select the load that you want to remove, turn on the toggle load, just check this on. Okay, click on assign and click on that beam, it will remove that load. Simple as that. Okay, same thing for this load. If I want to remove this load, select this. Okay, this will be unchecked, you have to check it on. Toggle load, you have to check it on. Okay, click on assign and just come and select it over here, it will remove. If you just select here, it will not work. Okay, I will double click it to assign it again. Okay, so toggle load in the sense, it will just remove your load. I'll just select this again, it will go. I'll say I'll keep it here, it will come back. Okay, wherever the load is not there, it will assign the load there, and where the load already exists, it will remove it from there. Okay, like this it can work. All right, so toggle load is very important, because next I'll be showing you how to do your slab loads and everything on wall loads and everything. All the major loads will come. Okay, so knowing this this thing will come very handy. Okay, so I hope you have understood everything. See you guys in the next class. Thank you.